All right, girls, we've got two more examples to take a look at. And these ones are going to be ever so slightly more involved because we're going to be working with reciprocal functions and with tangent functions, which means we have ever so slightly more consideration than just looking for an x or y value once we've isolated to one variable or to one value for our variable. So let's go ahead and start off with example number 3, where we're solving the expression -2 times the cosecant of x plus 1 is equal to 5. So just like before, our approach needs to be to isolate the trig function to then get the value by itself. And once more, we're working with the restrictions of our angle value of x or theta being on the unit circle, so between 0 to 2 pi. So to begin here, I'm going to go ahead and subtract 1 from both sides. So I'll end up with -2 times the cosecant of x being equal to 4. From there, I need to divide both sides by -2. And so 4 divided by -2 is going to give me a cosecant of -2. Once I get to one trig function, like what I have here, I can undo the trigonometric function by taking the inverse. So I can say the inverse cosecant of cosecant of x is equal to the inverse cosecant of -2. So the inverse cosecant, regular cosecant cancel each other out, and x is going to be equal to the inverse cosecant of -2. Now, anytime you're doing inverses that involve reciprocal functions, you want to think through your reciprocal identities. So remember, the trig ratio cosecant of x is equal to 1 over sine of x. If you had secant, that would go along with cosine, or cotangent would go along with tangent. So instead of trying to figure out flipped reciprocal values on the unit circle, I can always just take the inverse, so I can take 1 over the value that I'm working with the reciprocal in order to work with a regular trig function. So I can also say that x is equal to the inverse sine of -1 over 2. So notice how flipping from a reciprocal to a sine, all that I did was take my original value of -2 and I did 1 over that value, so 1 over -2. The reason I want to do that is then I'm just asking myself on the unit circle, where is my y value equal to? -1/2. And that's a much easier question than trying to reason through the cosecants as we go around the unit circle. So as we start to look, we're looking at our y values, and the first -1/2 for a y value happens at the angle of 7 pi over 6. So we can say x is equal to 7 pi over 6. And then we're going to have one more on the unit circle here. So we keep looking for a -1/2. And the next one happens right here with the angle value of 11 pi over 6. So we say x is equal to 7 pi over 6 and 11 pi over 6. So my hope for examples number 1 through 3 is that they feel pretty straightforward and that in many ways they feel like review. Because after you get the trig function isolated, the evaluation part is stuff that we've done before and that we've been doing for a while. So really the only thing new that we're taking a look at here is how to isolate the trig expression by itself from an equation. And as you might be able to predict, we're going to get to a little bit more complexity in our equation. So we'll see some that may involve techniques of factoring, some substitution steps, but the fundamentals always come down to if we have a trigonometric equation, we need to get the trig value by itself. And specifically, if we're working on the unit circle, we just need to take an inverse that we can solve for. So we're going to do one more example today, and then we'll get to some more practice and some different kinds of equations in class tomorrow. So let me scroll down and let's check out example number 4. So this one, in many ways, is one of my favorites that we do here. So let me grab my little electronic pen here. And you'll notice that this one is going to be really similar to everything that we've done so far with one exception. So here we have 3 times the tangent squared of x minus 6 is equal to 3. So once more, we need to get the trig function by itself. So our first step here to start doing that can be to add 6 to both sides. I'm going to add 6 here and add 6 here. So we'll have 3 times the tangent squared of x is equal to 9. From there, we can divide both sides by 3, and we'll have that the tangent squared of x is equal to 3. So here's where we have one different step from what we've seen previously. We have a squared expression, and so just like we've been doing with some of our identities work, if we have something squared and we're trying to solve for it, we just need to take the square root of both sides. When we do that, we're going to end up with tangent of x being equal to the positive square root of 3, but also that tangent of x is equal to the negative square root of 3. So remember that anytime you take a square root, so anytime this operation happens, you have 2 answers to consider, one that's positive and one that's negative. So that means we have 2 different operations that we're going to solve. Once we get tangent by itself, we can go ahead and undo the tangent to get x all alone by taking the inverse tangent. So we can say inverse tangent of the tangent of x is equal to the inverse tangent of the square root of 3. So the tangents will cancel, and we'll have x being equal to the inverse tangent of the square root of 3. So that's one of our operations. I can do the exact same process over here. Inverse tangent of x being equal to the inverse tangent of negative root 3. Inverse tangent and tangent cancel out, and I'm left with x is equal to the inverse tangent of the negative square root of 3. So then I just need to evaluate those 2 operations. Inverse tangent of positive root 3, inverse tangent of negative root 3. So this is where our tangent identity comes into play. So remember that sine of x divided by the cosine of x is what gives us the tangent of x. So I'm looking for a tangent value of root 3 and minus root 3. When we're operating on the unit circle, we end up with a tangent value of root 3 when sine is root 3 over 2 and cosine is 1/2. Because when I have that ordered pair operation, the 2's cancel out and I'm left with root 3 over 1, so root 3 here. So what I need to do is to hunt around the unit circle for an ordered pair set. Oops, that one shouldn't be square root, where I have an x value of 1/2 and a y value of root 3 over 2. So that's going to be the first one that I look for. So I'm checking out for that ordered pair, and the first place I find it is right here. So that value, that angle value, is pi over 3. So we can say x is equal to pi over 3. Then the other place where I'm going to get that positive result is when these are both negative, because then if I were to divide them with tangent, the 2 negatives would cancel. So I keep going around the unit circle, and the next place I come across that relationship, is not right there. Is this my eraser? There we go. Picked the wrong angle value. I'm looking for my y value of root 3 over 2. So that's this expression here, or 4 pi over 3. So x is equal to pi over 3 and 4 pi over 3. But unlike the other equations that we solved, we don't just have 2 solutions. We have 4 solutions because we have 2 different equations that we were solving for once we split apart at this point due to the square root. So then I need to look for values that are going to result in negative root 3. which means I need the same ordered pair, but one positive and one negative, or those signs flip-flopped around. So I'm still looking for the same x and y, but I need the signs to be opposite. So the first place that happens is right here at negative 1/2 root 3 over 2. So our x value there is equal to 2 pi over 3. And then I have to keep going around to look for where I end up with another mismatched signs, but the x value being 1/2, y value being root 3 over 2, and that happens here at 5 pi over 3. So that's going to be my final answer here. So all 4 of those values are solutions to my original equation. So if I take pi over 3, 4 pi over 3, 2 pi over 3, or 5 pi over 3, and I plug it back into the x value in this original equation, I will get a true solution when I solve out. So you'll have a couple of square values as you go through your homework, but you've got the rest of class time to get working on those. Please email me if you have any questions while you're getting started on tonight's homework, and we'll review those solutions in depth together tomorrow.